Welcome to my channel. This is Franco Pantaleon. In this video, we will take up exponential functions. We'll be taking up exponential function with base A and graphing exponential function with base A and natural exponential function and graphing of the natural exponential function and creating an exponential model for spread of virus. So this is the definition of our exponential function with base A. It follows this equation. So we have f of x is equal to a to the power of x. Take note that we have these different examples. So we have f of x is equals to 2 to the power x. Our base here is 2. And we have g of x is equals to 3 to the power of x. Our base is 3. And we have h of x is equals to 10 to the power of x. Our base is 10. So that is how we define our exponential function with base A. Okay, so what we will do now is we will draw the graph of each function. So we have f of x is equals to 3 to the power of x, and another function g of x is equals to 1/3 to the power of x. And by the way, guys, we already have the corresponding values for these different functions from -3 to +3. Now anyway, to make our life easier, I will show you how to create this table using your calculator. If your calculator have a table function, then you can easily create this table here. So our first step is we will be looking for our table function. So we'll press mode, and in this case our table function would be in for number 7. So we'll press 7. So we are now ready to input this value. So first we'll input this value f of x equals to 3 to the power of x. So we press 3 to the power of, we press this, and x. So we press alpha x. That's it. We press equals. So we'll start with, in this case we'll start with -3. So we press -3 equals, and our end would be +3. So we'll press 3, and our step would be, the steps would be only 1. So 0 to 1 is 1. So our increment would be 1. So we press 1 equals, and there you go. We already have our corresponding values. So this is in decimal form. We'll press SD, and there we have it. For value of f sub x, f of x is equals to -3, or f of x is equal to 1/27. So that is how we get this value. So we will automatically, we have the corresponding values for our f of x. So when f of x is, when x is equals to -2, so we have 0.111. We press SD, then we have 1/9, which is exactly this value here. Okay, next, when f -1 for value when x equals to -1, we have f of x is 1/3. So that is how we get the value. Next, 1, and when x equals to 1, we have value of 3. When x equals to 2, the value is equal to 9. And when x is equals to 3, the value is 27 for f of x. So we have easily determined the value of our f of x for this particular function here, for when you have 3 to the power of x. So you can now easily plot your function. So for y equals to 3 to the power x, this is the corresponding graph. Now, for g of x is equals to 1/3 to the power of x. So we'll press AC. And we might as well delete the value 3. And it would be a lot better if we will use the parentheses. And so we press the left arrow, we press this key here, and we provide the values 1/3. Okay, so checking our equation. Okay, we'll press equals. We'll start again. We'll start with -3 and we'll end with 3. And again, our step increment would be 1. So there we have it, our corresponding values. So we have for when x equals to -3, it would be 27. Okay. Next is 9. Next is 3, 0, 1, and 5. 1 is 1/3. When x is equal to 2, our g of x is equal to 1/9. And last but not the least, when g of x equals to 3, our value is 1/27. So we have plotted now our corresponding function when g of x equals to 1/3 to the power of x. Okay, next. So this is our definition of natural exponential function. F of x is equals to e to the power of x. Now, in this case, our base is e, and which is referred to as the exponential function. So, what if we are required to sketch the graph of each function? So we will graph this function and we will likewise graph this function. So we'll do the same. Okay, we will solve that with our calculator. Okay, so take note, our f of x will press, our e is somewhere here, shift e to the power of x, alpha x equals. So again, we'll start with -3 and we'll end with +3. And our step is 1. Okay, so outright we have our values. So we have when x equals to -3, our value is 0.049. When x is equal to -2, our value is, for f of x equals to 0.1353. And when x is equal to -1, our value would be f of x 0.3678. Continuing 1. When x equals to 1, we have value 2.718. And when x equals to 2, for function, we have our e, f of x, which is equals to e to the power x equals to 7.3890. And last but not the least, when x equals to 3, our f of x will be 20.0855. Okay, so we will now write down our corresponding value. So we have x -3, -2, -1, 0, 1, 2, 3. Now our f of x is equals to e to the power of x. is equals to, which we have previously solved or determined through our calculator. Okay, so we'll write down our values. So we have, okay, 0.0, we'll run this off to 2 decimal places only for simplicity, and 0.14, and when x equals to negative 1.037, and 0, 1, we have 2.72, and we have 7.39 and 20.09. Okay, so we mark such that there will be no confusion. And when our f of x is equal to e to the power of negative x, again we'll be using our calculator. So we'll simply add a negative sign, and okay, again we'll start with negative 3, we'll end with 3, and our increment, our step is 1. So we have these values. So we have 20.085 or 20.09, which is simply this value here. So when x equals to negative 3, for f of x equals to e to the power negative x, the value would be 20.09. Okay, checking the values. So the pattern is simply for when x equals to negative 2, the value is 7.39. So if we notice, this is just our value in reverse, starting with this value here. So having checked these values, we will simply write down the corresponding values in reverse order. So we have, so when x equals to negative 2, we have 7.39, and we have 2.72, 1, and 0.37, 0.14, and 0.05. And of course, if we plot these functions, then our e to the power x would be this graph here, and our e to the power of negative x is this graph. Okay, next, an exponential model for the spread of virus. An infectious disease begins to spread in a small city of population 10,000. After T days, the number of persons who have succumbed to the virus is modeled by the function. So we have b sub t is equals to 10,000 over these expressions here. So we are asked with this question, how many infected people are there initially at time t equals to 0? And find the number of infected people after 1 day, 2 days, and 5 days. Okay, so again, we will use the table function. So we'll use the parenthesis sign. We have 10,000. No, we will use parenthesis rather. 10,000 divided by this expression here. We have 5 plus 1, 2, 4, 5 E. E, we have shift E to the power of, so we'll use parentheses such as negative 0.97 t. So in this case, we'll simply use x negative 0.97 alpha x, close parentheses, and again close parentheses, equals. So we'll start with t equals to 0 and until the 5th day. The end would be 5th day. Our increment would be 1. Okay, so we have these corresponding values. So how many infected people are there initially at time t equals to 0? So our answer here would be, based on the result, we have 8. Okay, this is our answer for letter A. Next, find the number of infected people 1 day, 2 days, and 5 days. So we'll inspect 1 day would be 20.97, 2 days would be 54.37, and the 50 would be 678. So in this case, since we are required to determine the number of infected people, then we'll round off our result to the whole number. So in this case, for after 1 day, there will be around 0, 1, 2, and 5th day, when time 0, 1, 2, 5, and the number of infected people. So the number of infected people would be, if we plot this out, 8. And for x is equal to, after 1 day, is equals to 21. We would expect there will be 21 infected people with the virus. And time t equals to 2, we have 54. And on the 5th day, we have 678. Okay, so that's it. If you like the content of this video, click like and subscribe. And thank you for listening. Bye bye.